Hey everybody, in this video we are going to answer a bunch of questions here, figuring out the amplitude, the period, and the phase shift for each of our four graphs, so the four separate videos, and then we're going to graph one period of the function. So let's dive into this. The amplitude is always the absolute value of the number being multiplied in front of the trig function. In this case, the number out front, which we refer to often as A for amplitude. A is -3. That means the amplitude is 3. Okay? That means your distance going up and down from your midline will equal 3. All right? The period. The period is determined by the formula, in this case, 2 pi over b, and b is found right over here. We can't really see it. It's really 1 times x plus pi in this case. So the b is 1, and 2 pi over 1 is 2 pi. That is the horizontal length from start to finish of one complete cycle. The length is 2 pi in this situation. So from one starting point to the next, the piece of the graph, the periodic portion that repeats itself over and over, is 2 pi. If you do recall, I referred to each of these spaces as a quarter, which was 1/4 of the period. So a quarter would be 1/4 of 2 pi. If I reduce, that is pi over 2. So that's going to be the distance in between each of these 5 tick marks right there. There are 4 spaces. It's pi over 2. The phase shift. The phase shift has to do with our left or right shifting. So in this case, plus pi. That means we went negative pi, or we went, if you want to use full description here, left pi. All right. So that means this first tick mark is at negative pi. That's where I'm starting. Now I might need a common denominator since I'm adding this. So I'm going to rewrite that negative pi as negative 2 pi over 2. That is the same as negative pi, just with a denominator of 2. If I add q each time, that makes this negative pi over 2 right here. That makes this 0. That makes this, because it's 0 pi over 2, negative 1 pi over 2, 0 pi over 2, 1 pi over 2, pi over 2, and then 2 pi over 2, which again is the same as pi. Beautiful. Those are my 5 x values in question. Those are kind of my critical numbers, the numbers I care about at this particular moment. You can't really see my pi. Same thing. Oops. Let's do, oops. Just going to squeeze that in there a bit. 2 pi over 2, also known as pi. Okay, so those are the 5 numbers I care about. What else while we're at it? So I did all that. Phase shift, done. Period, done. Amplitude, done. Now I also have -2. That's your midline or your sinusoidal axis. So -2 is here. If that's -2 and I take my amplitude into account, -2 plus 3 is +1 up here. And down here, -2 minus 3 is -5. -5 is right there. Then the cosine graph shape. Normally the shape of cosine is going to look the one more like a C. If it's positive, oh no, you're not going to see it if I draw it there. If it's positive, it looks more like this shape right over here. If you forget where to get that from, you are going to mentally reference the unit circle. What is cosine equal? It goes 1, 0, -1, 0, 1, and that's this shape. 1, 0, -1, 0, 1. If there's a negative out front, that's a vertical reflection. So that took my graph and reflected it vertically. So it is now upside down. Oh, and I said it looked like a C because that's like cos, and then you'll see sine, kind of looks like an S. So then here, if you see I flipped up there, do not go down like this. No, that is not what it does. Okay? So here we go. Try to draw that concavity correctly, but that is a little bit more than 1 period, but that is 1 period. If you truncate means you're like kind of chopping your graph off. So if you truncate just to draw the one exact period, you want to be real specific, that's fine. But, you know, make sure you're just being explicit with the directions. And if you're asked about domain and range, it's still got a domain of negative infinity to infinity. And the range is -5 to 1, both with brackets. La-di-da, that's the end of this example. If you need more, I have an entire Trig, graphing Trig playlist, including lessons and including examples. I will try to include that new playlist at the end of this video, similar to how I included the exponential and log playlist at the end of those videos, and the graphing rational function playlist at the end of those videos. They're all in the description box. If you can appreciate all of this description, thumbs up. If not, you still confused and sad, thumbs down. But if you're confused and sad on this, like, you're in pretty rough shape if you're taking a final exam. I'm not going to lie, and I'm not trying to be a jerk. I'm just telling you the truth. So you need to really, like, buckle down. You know, the clock's ticking, my friend. Okay? So that's it for now. Adios.